In this video, we're just going to start by looking at another example, applying what we've learned so far. So you could always pause the video and work the problem. I'm going to first go ahead and make sure we have some numbers labeled correctly before we kind of continue on. But then you can kind of pause it, try a step, and then see if you match what I get. So we're trying to estimate the percentage of women in the United States who have C-sections who have serious complications. So we took a random sample of 1,200 C-section births. So that's getting us our N. And we found that 148 of them have experienced serious complications. So then my P hat would be that 148 out of that 1,200, which again, carrying more decimals here, I'm going to carry 6. Gives me a sample proportion of 0.123333. You're also given a little picture so you can kind of see those that did not have complications versus those that did. And so there's where you're seeing our 0.123. Here they just rounded it to 3 decimal places instead. You're going to be doing a 96% confidence interval, and you're going through all those steps just like we did with this example. So again, if you want to try the first step and pause here, then you can see if you get it correct. Alright, so for our first step, so we're trying to define P. Again, that's our population value here. That's our population proportion of U.S. C-section births. I do want to be careful of including the country because I do believe medical care differs greatly depending upon what country we are in. So I think it's important to have the U.S. part here. We are only looking at C-section births, and then looking at the proportion of those that have serious complications. So that's what step 1 should look like. Right, if you want to again try step 2 here first by pausing the video and then seeing if you match mine, feel free to do so. Alright, so now looking at the conditions. So do we have any concerns about our sample? It says we took a sample across the United States of C-section births, so that's who my population is, so that seems not to be a problem to me. Now for my N times P hat and N times 1 minus P hat, I just actually did some counts here, which is really nice if you realize what those values are. So if I take N, 1,200, times P hat, which is 148 out of 1,200, those 1,200s are going to cancel and just leave me with 148, or basically in our example, the number that had serious complications. Then the N times 1 minus P hat, because you'll notice that the two numbers we have here are going to add up to N. So I kind of know by default that that's going to be 1,052. So what that 1,052 represents are the number that did not have serious complications. So 148 had serious complications, 1,052 did not. Both of those numbers are at least 10. So the conditions are met here. Step 3 is where we're doing the actual calculation. So again, if you would like, pause the video here and see if you match what I get. So first I needed to get my Z, which was 2.054. Again, just using that little chart where you can write these numbers on your Z table. Alright, and then sorry, I had to write over my graph here to write the full thing out. So I have my P hat, my 0.123333, minus my Z, times that square root piece of the P hat, 1 minus P hat over N. Same thing over here with just the plus sign between it. So first just starting, making sure you have the right numbers to begin with here. Then I'll carry on the math. So now I have all of my math worked out. I carried at least 6 decimals until the very end, at which I rounded to 4, which is generally what I ask you to do as well. So first finding that square root piece, I got 0.009492. Multiply that by my 2.054 to get the 0.019496. And then finally did our subtraction and our addition with rounding those to 4 decimals. Got those values. All right, the last step is just doing the interpretation. Again, usually before I do that, I change these to percentages by just multiplying by 100%. So this would be 10.38% to 14.28%. So again, if you want to try the interpretation here first, you could pause the video and then see if you match me. So then looking at our interpretation, so I am 96% confident this time that between our values, so 10.38% and 14.28% of U.S. C-section births have serious complications. So another example of all 4 steps worked out. Now let's relate those values that we did to some of the terms we defined. So remember that standard error is just the name of an estimated standard deviation. So this square root piece up here is my standard error. So what did I get when I did that square root piece? I got this 0.009492. So that piece is my standard error. The other piece I circled after we multiply our standard error by RZ is that margin of error. So our 0.019496 is the margin of error. Right, finally, based upon our confidence interval, could you conclude that more than 10% of U.S. C-sections have serious complications? So looking at our interval, is it more than 10%? More specifically, is the entire interval more than 10%? Well, yes, so then my answer here then will also be yes, because my entire interval is above 10%. Again, even if just a little part of that interval was not above 10%, then my answer would have to be no. Right, so that was another example of everything worked out. We do have another new topic to cover in the next video, where I mentioned sometimes how big of a sample do I really need. That's what we're going to start talking about in the next video.